my dear students. Welcome to ME Education. Today we are going to discuss a very interesting topic, electric current and circuit. In this session, first we can focus on properties of electric charge. Then electric conductors, electric insulators. After that, we can define electric current. Finally, we can introduce electric circuit by end of the session. Let's start the session. As a first step to become expert in electricity, the basic building block to understand electricity chapter is electric charge. Now, let's have a look on the electric charge. What is meant by electric charge? Electric charge is the physical property of a matter that causes to experience a force when it is placed in electromagnetic field. See the definition of electric charge. Here, electric charge is the physical property of a matter. Matter means it is having mass. You already know bodies are having masses. Similarly, in electricity, we need to talk about electric charges present in the body. Okay, so every body consists of mass. Every body having full of electric charges. These electric charges causes to experience a force when you place this mass or body in the electromagnetic field. Okay, you will be calculating the magnitude of electrostatic force between two charges by using Coulomb's law in IIT Foundation Advanced Level course. Now have a look on the another definition for electric charge. See that the property of a proton or an electron which gives rise to electrostatic force between them is called electric charge. Just now we have given so procedure to determine electrostatic force between two charges by using Coulomb's law we can discuss in IIT Foundation Advanced Level course. Okay, now you will get a doubt. What are the different charges we need to discuss in electricity chapter? We are having two types of charges. One is positive charge and negative charge. We need to play the game with electric charges to become expert in electricity. Okay, so now it is a physical quantity. Okay, electric charge. Here, SI unit of electric charge is Coulomb. What is the SI unit of electric charge? Coulomb. Now, 1 Coulomb is equivalent to 6.25 into 10 to the power of 18 electrons. Now, I will give you wonderful relationship between electric charge and the number of electrons. Write down Q equivalents to Q is the electric charge. Q equivalents to plus or minus number of electrons. E is the charge on electron. Okay, now you can have a look on the properties of electric charge. This is wonderful relation. You will be applying this equation in upcoming slides. This is the relationship between electric charge and the number of electrons. See here, invariance of charge. It is one of the property of electric charge. Invariance of charge is nothing but every proton or electron, neutron, alpha particle are having fixed value regardless of its speed. What does it mean? When electron is at rest or in motion, the value of electron can't change. Okay, the charge on the electron always having a fixed value even though it is at rest or in motion. That is the invariance of charge. Let's have the definition. Electric charge invariance refers to the fixed value of a charge of a particle regardless of its speed. For an electron having a charge of 1.6 into 10 to the power of minus 19 Coulomb, which is independent of its speed. Okay, what is the charge on electron? 1.6 into 10 to the power of minus 19 coulomb. This value never ever changed. Okay, even though electron is at rest or in motion, that is the invariance of the charge. Now let's have a look on the particle, its charge and mass. First, proton. Proton having a charge of plus 1.6 into 10 to the power of minus 19 coulomb and its mass 1.6 into 10 to the power of minus 24 grams. Coming to the electron, coming to the neutron. Here, charge on the neutron 0, mass of the neutron 1.6 into 10 to the power of minus 24 grams. Coming to electron, electron mass and its charge is very important to solve the problems. Okay, see the what is the charge on electron? Minus 1.6 into 10 to the power of minus 19 coulomb and its mass 9.1 into 10 to the power of minus 28 grams. Coming to the alpha particle, what is the charge on alpha particle? Plus 3.2 into 10 to the power of minus 19 coulomb and its mass 6.64 into 10 to the power of minus 24 grams. In this, you no need to remember all the values. Okay, just remember the values for electron. What is the charge on electron and its mass? That is enough to solve the problems. What is the charge on electron? Minus 1.6 into 10 to the power of minus 19 coulomb and its mass 9.1 into 10 to the power of minus 28 grams. Here, magnitude of one charge on electron is nothing but, just now we have seen 1.6 into 10 to the power of minus 19 coulomb. Here, 1 coulomb equals to 6.25 into 10 to the power of 18 electrons. How to prove this? See, just now we have given the relation between electric charge and number of electrons. Number of electrons present in 1 coulomb of electric charge. See this, Q equals to plus or minus NE. Okay, so 1 coulomb of charge, number of electrons always having a positive value. Here, what is the charge on electron? Minus 1.6. Here you can take minus or else you can put plus, take the magnitude of charge on electron. Here number of electrons, now I am taking magnitude 1.6 into 10 to the power of minus 19 coulomb. Okay, now number of electrons present in 1 coulomb of charge. 1 coulomb by 1.6 into 10 to the power of minus 19 coulomb. If you calculate, you will be getting 6.25 into 10 to the power of 18 electrons. That means 1 coulomb of charge is equivalent to 6.25 into 10 to the power of 18 electrons. Now, see this one more property of electric charge. Unlike charges will attract, like charges will repel. We already know this point. It is very popular property of electric charge. Unlike charges will attract with each other, like charges will repel each other. Okay, so first take two unlike charges. Unlike means positive charge and negative charge. These two unlike charges will attract with each other. Now take two positive charges. Two positive charges means what? Like charges. Like electric charges will repel. How they are repelling? Just observe. Okay. Like charges will repel each other. Now coming to two negative charges. Two negative charges are nothing but like charges. Like charges will repel. Observe. Okay. Here, unlike charges will attract each other and like charges will repel each other. Okay. So, in this manner, two positive and negative unlike attract each other. Like charges will repel. Okay. It is one of the property of electric charge. See this? Unlike charges will attract, like charges will repel. See this, unlike charges will attract. Like charges will repel. Like charges will repel each other. Okay. So this is one of the property of electric charge. We can see additivity property of electric charge. Additivity of electric charge. To determine net charge in the system, we need to calculate algebraic sum of the all charges present in the system. See this, for an isolated system, the net charge is algebraic sum of all charges present in the system. Here it's an isolated system. It consists of different charges, positive charges and negative charges. Q1, Q2, Q3 are positive charges, minus Q4, minus Q5, minus Q6. These three are negative charges. To determine net charge of an isolated system, we need to apply additivity of charge. What is the net charge? Net charge is represented with capital Q. Capital Q. Capital Q is the net charge of the system. It is algebraic sum of all individual charges present in the system. Here plus Q1 plus Q1 plus Q2 plus Q2 plus Q3 minus Q4 minus Q5 minus Q6. This is the procedure to determine net charge of the system by applying additivity of the charge. Now, let's have a look on the law of conservation of charge. Conservation of electric charge. Electric charge always conserved. Electric charge neither be created nor be destroyed, but it transfer from one body to another body. To explain in detail about law of conservation of charge, I want to take sodium chloride formation. Sodium chloride, here sodium atom, first take sodium atom, chlorine atom. What is the atomic number of sodium? 11. That is why it is having 11 protons and 11 electrons. Chlorine, what is the atomic number of chlorine? 17. 17 is the atomic number of chlorine. Chlorine contains 17 protons and 17 electrons. Here, one electron will transfer from sodium atom to chlorine atom to form sodium chloride, that is salt. Now see transfer of electron from sodium to chlorine. Just observe here how electron is transferring and what will happen after transfer of electron from sodium atom to chlorine atom. See this, one electron is transferred from sodium atom to chlorine atom. Now what will happen? Sodium chloride. Okay? So initially sodium atom consists of 11 protons and 11 electrons. Chlorine consists of 17 protons and 17 electrons. Now, one electron is transferred from sodium atom to chlorine atom. What will happen? Tell me. Here, initially 11 electrons, one electron is transferred. Finally, 10 electrons will present in the sodium atom. After that, one electron is received by the chlorine atom. Here, 18 electrons. Initially, 17 electrons. After receiving one electron from sodium, finally, 18 electrons present in the chlorine atom. Okay. Now, what is the net charge on sodium? What is the net charge? Tell me. 11 protons. That means plus 11. 10 electrons minus 10 electrons. What is the net charge on sodium? Plus 1. Just observe, plus 1. You will be getting net charge on sodium here plus 1. Plus 1. What is the net charge on chlorine? 17 plus 17 minus 18. That is minus 1. Minus 1. That is why Cl minus, net charge on chlorine after gaining of one electron. An electron gained by the particle, so it attains the negative charge. When you remove the electron from a particular particle or atom, understood na? Here it gains positive charge. Electron removed from the particle, it attains positive charge. Electron gained by the particle, it attains negative charge. So we proved that net charge of the system always same. Okay, na? Understood na? Always constant. There is no destroying and creating of electric charge. Electric charge neither be created nor be destroyed, but it transfer from one body to another body. Okay, here we have seen transfer of electron from sodium atom to chlorine atom and formation of Na plus and Cl minus. This is all about law of conservation of electric charge.